Good morning, fifth graders. Happy Monday. Today is Monday, May 4th, 2020. Hope you guys had a good weekend. So let's get started with our science lesson. This lesson today is actually a review because we've talked about the states of matter. We had a very good lesson on Friday with the students that were able to attend the session, and you guys did a very good job. I liked it. I liked it a lot. So let's take a look at changes of state. Let's review, and I repeat, this is some things you should already know because we discussed it in class. We have states of matter. Now, if it is rigid, has a fixed shape, and a fixed volume, what state of matter is that if you can't squash it? That is your solid. This is what your molecules look like. Remember, they're very rigid. They're very close together. All they're doing is just vibrating back and forth. Now, these molecules are going to represent what state of matter that is not rigid, does not have a fixed shape, and is not fixed with this volume. Now, I see a vocabulary word volume. What is volume? Remember, that's a math word. So those of you that's paying attention in math, you should have a very good visual of volume. Volume was holds space. And in this state of matter, it cannot be squashed. So this represents which state of matter? You're correct if you said liquid. Now, this third state of matter, it is not rigid, does not have a fixed shape, does not have a fixed volume, but it can be squashed. What state of matter is that? That state would be gas. Now remember that liquid and gas, the shape that it has is the shape of its container. We know that a solid is going to have the shape of whatever material that it is. Liquid and gas shape is based on the container on which holds it. Why do you think that container has a lid? Because you see the gas, you see the liquid, and you see the solid. And you see how the molecules are moving in those containers. But on the gas container, it has a lid on it. Why do you think that container has a lid? If you said to hold in the gas molecules, you're absolutely correct. Because remember, the gas molecules are all around us. We can't see the gas molecules. How do we see the gas molecules? Good. An example would be steam. How do we see steam? We can't see the gas around us, but we know it's there because we're breathing. But we can see steam, and we know steam is a gas. Why do we see steam? You're so smart because the molecules you see they're bumping into each other. So that's why you see steam as a gas, those molecules bump into each other, but we don't see the actual gas that we're breathing. So I keep saying the three states of matter. And I noticed in our Friday session, you guys, the group that drew your states of matter, you drew the molecules perfectly. But remember, there's another state of matter. It's more than just three, it's actually four. What is that fourth state? Plasma. Remember, plasma is actually the fourth state of matter. So we have four states of matter, not just three. So plasma is created by adding energy to the gas so that some of the electrons leave its atoms. So this is what that would look like if you was looking at the molecules of plasma. Okay, so that energy gets released. This is some real world, because y'all know how I am about real world examples. This is a real world examples of plasma. Lightning, the sun, a nebula. Okay, fifth graders, what is a nebula? I think I heard you say a new star. At least is what you should have said. Remember, a nebula is a new star. We talked about that in our space unit. Neon lights, that is a nebula. Now, we haven't talked about an aurora, which is a nebula. Auroras are particles from the sun that interact with gases in our atmosphere, causes beautiful displays of light in the sky. So these are examples of plasma, the fourth state of matter. This right here shows you what those molecules look like. Now remember, we said that it adds energy to the gas so that some of the electrons leave. You see, when the electrons leave, it's almost kind of like an explosion. This is why you notice in all of these examples of plasma, you see like a pop. You see like an explosion of energy. That's plasma. Now, we made plasma in class. And what did we call it? What was the name of that plasma we made in class? If you said goo, you are correct. But the science word is called oobleck. Oobleck. Remember how we made out of cornstarch and water and we put it in our hands when we squeeze? It's a solid. And when we release it, it becomes a liquid. So remember, your plasma goes from liquid to solid. And you can see that very well when you look at things that are neon. You can kind of see that very well. So remember, those electrons get loose once the energy is released. That picture is showing those electrons getting loose. So that is plasma. That is our fourth state of matter. Losing electrons. So now let's go to today's lesson. Wondering what happens when matter changes state. Imagine a hot summer day. You visit an ice cream stand for a cold treat. When you get your ice cream cone, the ice cream scoop on the cone is round and solid. What happens after a few minutes in the sun? Very soon, drips of liquid ice cream are running down the cone, just like in the picture. You try to keep up with the melting ice cream, but it quickly becomes a gooey mess. Think about this. Why did the ice cream change so fast? How about other changes of state? Remember, matter also can be a gas. How do you turn a liquid into a gas? So here I have a liquid and we changed it into a gas. How did we change it into a gas? The same reason. Why did the ice cream melt so quickly? That's another question that you should have answered in your head. How do you turn a liquid into a gas? You have a visual. Or how do you change your gas into a liquid? Once again, put the answer in your head. You have a visual, or say it out loud, or tell your parent, tell your puppy, tell somebody. In this concept, you will explore and learn about all the different changes of state. You also will discover what happens to matter when it changes states. So these are state changing. When I talk about phase changing or changes of state, I'm talking about it goes from one state to another state, goes from one state to another state. It goes from one state to another state. That is what we're talking about when we say matter changes state, or you may hear the word phase change. It means it's going from one state to another state. That is what we mean by changes of state. So, how can you change the phase or the state of matter? We have a solid, we have a liquid, and we have a gas, because you know the name of the states. Phase changes will happen when you get a temperature change. So this represents a temperature line. We start at the blue for solid, and as we go up, you notice the color changes, and then we end up with the red to represent the gas. As the temperature change, the state will change, either from solid to liquid, liquid to gas, gas to solid, liquid to gas to liquid, etc. When the temperature changes, you're going to get a freezing point and you will get a boiling point. So the freezing point of water, that means the temperature at which water changes from a liquid to a solid. Now, we talked about this in class. Tell yourself, turn and talk to yourself and say, self, what is the freezing point of water? And I have given you a clue, and in the picture, you see it going from a liquid to a solid. 0 degrees Celsius or 32 degrees Fahrenheit. That is the freezing point of water. Now, we also talked about this in class. What is the boiling point of water? Turn and talk to yourself or to your pet or to whomever. What is the boiling point of water? That is 100 degrees Celsius. So to get the boiling point is 100 degrees Celsius. Remember, we always talk about metric in science. Fahrenheit will be standard. Celsius would be metric. So changing states of matter, that simply means a substance gain or lose energy, their state or matter will change. So if it gets vaporized, it's going from a liquid to a gas. If we're having condensation, we're going from a gas to a liquid. We have freezing, it's going from a liquid to a solid. If we have melting, it's going from a solid to a liquid. Now I see a vocabulary word, sublimation. What was sublimation? And no, it is not when plants sweat. That's transpiration. Sublimation means it skips the liquid step. Sublimation means it goes from a solid to a gas or a gas to a solid. That is sublimation. And then we have deposition where it goes from a gas to a solid. Now, this picture also shows you what the molecules look like in that state. It shows you if I'm going from freezing, it shows you how my molecules, they change. If I'm going from a liquid to a gas, it shows you how the molecules would change. So we're talking about changing states of matter. You notice that if I go from a solid to a liquid to a gas, and a gas to plasma, I gain more what? You're so smart. I gain more energy. The energy goes up. It increases as you go from solid to liquid, liquid to gas, gas to plasma. And once again, you can see, because y'all know having by visuals, you can see how those molecules look in every state. The level is going to increase. The energy is going to increase. So if I remove energy, what does the energy do? It is going to decrease. So I have all these gas, they're all over the place, they're spread far apart. But as I go from a gas to a liquid, we see the molecules coming closer together and they're beginning to slow down. As we go from a liquid to a solid, you will see that those molecules are tight together and all they do is simply vibrate. Now we have states of matter, which is heat. We're going to look at heat first. So I want you to take a look at that picture and see what you notice. Now I gave you a lot of wait time. So you should have seen how heat induces change of matter. Let's take a look. We see ice cream that has melted. We see an egg that has been fried. We see popcorn kernels that have been popped. The candle, it was been lit, now it's a little lower. We know that water has changed its state. We see cookies that have been cooked. We see heat that has cooked the marshmallows. So let's move forward. Melting is the change of state from solid to liquid. It occurs when energy, usually heat, is added to the solid. As particles of the solid gain energy, the faster they move. Eventually, they move so fast they can slide past each other, and the matter begins to flow. For example, ice is a solid state of water. When thermal energy is added to ice, what will the temperature do? Correct. It's going to rise. And how will the water particles move? They're going to move faster. That's when we say something has melted. So if I have a solid, we know those molecules are packed tight together. As I add heat, the molecules start to separate from each other and they start to slide past each other. As I add more heat, those molecules even move further and they spread so far apart we can't see it, or they bump into each other, in which we have our steam. So that's what it would look like. It is changing state. They're moving faster. So how are evaporating and boiling different from condensation or condensing? Evaporation is the change of state from a liquid to a gas. Evaporation can happen in two ways. You either boil it or it evaporates. If you put a pot of water on a stove, it's going to gain heat, but you got to turn the stove on first, obviously. Eventually, the liquid water will change quickly to water vapor, and the large bubbles of water vapor rise to the surface of the water. This is called boiling, and it only takes place at a specific temperature. And what is that temperature? Remember, we talked about that a few minutes ago. 100 degrees Celsius. A slower process called evaporation can also change a liquid to a gas. Evaporation can take place at any temperature. For example, after a rainstorm, a puddle will warm up as the sun shines on it. The water molecules on the surface will gain energy first and then evaporate. And another word for evaporate is to vaporize, to become water vapor. Both evaporation and boiling occurs because the liquid particles do what? Turn and tell yourself. It gains energy. So we know in our illustration we have our water. It gets to its boiling point. It starts to evaporate, or it starts to do what? There's another word for evaporation. Vaporize. Now let's think back. Let's draw back from the first experiment that we did, which was a collapsing can. How did heat and the change in the phase of matter play a role in our experiment, the collapsing can? When you go to Kid Block, you're not going to Kid Block now. I'm going to say that again. Do not go to Kid Block now. You're going to do that after we finish our lesson. But here you have a visual to remind you. How did heat and the changing phase of matter play a role in that experiment? So we see remember we put the water inside the soda can, we put it on the stove, turn it upside down, and collapse. It went to the ice cold water and collapsed. How did the change of state? How did the change of matter? What changes of state were involved? Okay, so I'm going to give you one more time and look at that visual. Do not go to Kid Blog now. You're going to finish the lesson first. So can you think of other examples from changing solid to a liquid? I see our character thinking. Can you think of any other examples going from solid to a liquid? How about from a liquid to a solid? And then I want you to think about what can cause these changes. For example, what do you need to make water make ice cubes? So if I have a liquid, how can I make it to become ice cubes? What makes those ice cubes turn back to a liquid? Now, by the way, something just ran across my brain. Is this a physical change or a chemical change? I heard my smart fifth grader say this is a physical change. And why is this a physical change? Because it's still water. It's simply liquid to solid, back to a liquid. It did not change being water. It didn't become a brick just because you melted it. It's still water. So there's a physical change. So what made the ice cube turn back to liquid? Remember the very beginning we talked about this thing, temperature. Temperature, we added heat. The molecules move faster. So that was heat. Now we're going to take a look at freeze, how we can change state with freezing. Freezing is the change of state from liquid to solid. If you put a cup of liquid water in a freezer, the temperature would quickly drop. The liquid water would get colder and colder. As the particles of water lose thermal energy, they slow down and the liquid becomes solid ice. So therefore now the molecules are going to decrease. They're going to get slower. You're going to lose energy when the temperature drops. So how is melting different from freezing? There are all kinds of matter. As we classify matter in a variety of ways by its color or its texture, remember that's called properties. Properties is how you describe. Another vocabulary word came to my mind. Tell your partner, tell your parent, tell your pet puppy, what is qualitative data and what is quantitative data? So I'm going to tell myself, I know that quantitative data means anything with a number because I have the N in quantitative data. Now I'm going to tell myself, I know qualitative data means to describe. So if I'm doing classifying matter by color or texture, is that quantitative data or is that qualitative data? I'm going to tell myself, that's going to be qualitative data because it's describing the properties of matter. Now, another way of classifying matter is by the state it's in. That doesn't mean California, New York, Pennsylvania. That's not the state that matter is in. It's either a solid, liquid, gas, or plasma. Now, when we say that rock is a solid and milk is a liquid and air is a gas, we classify them by state. You already know that. We know that's also your physical state. So that is how melting is different from freezing. So condensing is a change of state from gas to solid. When gas particles cool down, they lose their energy and they turn from a gas to a liquid. Now, on a humid day, there's a lot of water vapor in the air. When those water molecules come into contact with a cold glass of milk, they lose their heat. And then they start to collect those small drops of liquid water. You see on here, it has those small drops of liquid water. What do we call those small drops of liquid water? Very good. You learned that in the water cycle. It is called condensation or it is condensing. What is a cloud? Small drops of water because of condensation went from a gas to a liquid. So it has condensed. It has condensed. Condensing. Condensing. So now during the cooling process, heat would be released from matter and the state of matter would change from a gas to a liquid and finally to a solid. And remember, those molecules are going to speed up in the heat, but they're going to get slower, which is why it goes from a gas to a liquid to a solid, because the molecules begin to slow down. So how does changing the state of a substance affect its mass? Now, if you eat all this chocolate, it's going to affect the mass of your body because you're going to gain weight. And this quarantine, man, oh man. Whew. Anyway, some physical properties change when a substance changes state. For example, a piece of ice loses its cube shape when it melts, but a change in state would not change the amount of matter in a sample of a substance. Remember, weight and mass is not the same thing. Mass is mass is mass. Whatever mass is in this chocolate bar, it says it has 10 grams. Another thought. Why does it say gram and not liquid, not liter or meter? Remember, gram measures how much something weighs. Now, mass and weight is not the same thing. Weight is what it weighs based on the gravity putting pressure on it. You don't weigh the same thing on the moon because of the amount of, or the lack of gravity. Mass will stay the same. Whatever's in this chocolate bar will stay in this chocolate bar no matter where it is in the world, in the universe, in the atmosphere. So its mass will stay the same, but its weight will change based on the gravity of where that chocolate bar is. Remember, mass is mass is mass. The mass did not change. If I take all this chocolate and I put it on the scale, and let's say it weighs 40 grams. And you notice I didn't say 40 liters, or I didn't say 40 what? Meters, because meter is length, liter is liquid. I say grams. If I take the solid and I put it here and melt it, it's going to weigh the same. Now, obviously, this picture and that picture doesn't stay the same because these are not the same. I had to find a picture that shows solid and liquid. But if I take all of this and I measure it, and then I turn around and melt it, it's going to have the same measurement. It did not lose its what? You're so smart. Mass. It did not lose its mass. Imagine you boil a pot of water. You weigh the water. Now, if you want to know how much energy was lost, what do you have to do? You have to measure how much water, and you're going to measure it in what? In metric. I think I hear you saying liter. You're going to measure the liter of the water. Put it on the stove. Let it heat. Make the molecules move faster. I see some steam, so we know those molecules are bumping into each other. Then measure it. Whatever it measures after you heat it, you know how much it has evaporated. You know how much gas, how many particles that you have lost. Okay? So when you boil something, you very well will lose some of its liters simply because of evaporation. It's going to weigh out. It's going to go out. Okay? So mass does not gain or lose unless it goes away. If you want to know how much it went away, you measure it first and then you measure it afterwards. So in conclusion, effective pressure. A change in the surrounding pressure can change the temperature that will cause the material to go from one state to another. This is because the molecules causing the pressure inhibits or prohibits the molecules of the material. So remember, if something is cooled down, the molecules are going to get slower. If it heats up, the molecules are going to move faster. You're going to gain energy, you're going to lose energy. So now test yourself. Let's see how you do. Number one, what is a change of state? In this activity, show what you know by matching the picture with the molecules. So which picture would go here? The first, the second, or the third? You should have said the snow. That is a solid. Which one would be the second one? What would go with these molecules? Which picture? Very good. That is your liquid. So just by common sense, we know the third one would be your gas molecule. So you have your solid, you have your liquid, and you have your gas. Very good. Now, when matter changes state, the total number of particles in the matter would change, or would it stay the same? Stay the same. So give yourself a pat on the back. Very good. In order for matter to go through condensation, tiny drops of water, its temperature must initially increase or decrease. If you said decrease, give yourself a high five because you were paying attention. In order for matter to go through boiling, its temperature must initially do what? Increase or decrease. I hear my smart fifth graders saying it's going to have to increase. So shake your hand. You're so smart. Now, when the temperature of the liquid is raised high enough, it eventually becomes a what? Does it become a solid? Does it become a liquid? Or does it become a gas? Ah, it becomes a gas. So pat yourself on the back. You got another answer correct. So now, Jeff is doing an investigation to prove that a sample of matter has the same mass before and after a change from solid to liquid. So I'm going to drag and drop the tiles to show the steps of the investigation in order that they should occur. So I'm going to give you about a minute to read your clues. And then you're going to figure out what will go first, second, third, step fourth, and step 5. So I'm going to give you a minute to read it. So what would go first? First thing we got to do, we got to put the ice cubes in a beaker. A beaker is simply a container. I've shown you beakers before. So we're going to put the ice cubes in the beaker. Remember, he's trying to prove that, now I'm going to phrase this. His claim is that matter has the same mass before and after a change in its state from solid to a liquid. That is his claim. Now he's going to get some evidence. He's going to prove it during his investigation. So the first thing he had to do is put the 3 ice cubes in a beaker. Now what would he have to do? He would have to weigh the beaker. Remember, I just said a few minutes ago, if you want to find out what was lost, you measure it before you complete or you add the heat. You have to measure it and weigh it before. So he has to first place the ice cubes in the beaker and then weigh the beaker and the ice cubes and write down the weight. Now, what is he going to do in step 3? He is going to have to put it in the microwave. 5th graders, do not put anything that's steel in the microwave, please. Anything metal in your microwave. So I'm sure he used something plastic or something that was microwavable. So he's going to put the ice cubes in the microwave. Now, why would he put it in the microwave? That would be your step 4. He needs to melt it. Okay, so he needs to melt the ice cubes. Therefore, step 5 would be now weigh it. So remember, he wanted to find out because his claim was that he had the same mass before and after he went from a solid to a liquid. So he put the ice cubes in a beaker. He weighed it. Then he put it in the microwave and he melted it. And then he weighed it again. Nothing was lost. So he's going to have evidence that's going to weigh the same thing. So very good. So this is what you're going to do. You're going to go to Edpuzzle, and I want you to look at the States of Matter rap song. It's about a minute something long. Then I want you to go to Kid Blog, and I want you to answer the questions. Now, 5th graders, some of you are copying and pasting. You're looking at the questions on Kid Blog, and then you go back to the internet, and you copy and paste the answer. Wrong. Do not do that, because first of all, I can tell you did it. I know how 5th graders write. I know your vocabulary, and I know how it looks when you copy and paste from the internet. It has a certain look. I need you to stop it. I need you to read the question. First of all, follow the PowerPoint video. Go to your Kid Blog. Read the question. Use what's in your brain. I got to get you ready for middle school. If you cheat and all you try to do is take a shortcut and you try to go to the internet and Google your answers, you're not learning anything. And it's going to show up in 6th grade. So go to Kid Blog. I want to see the answers that's coming out of your brain. That's the answers that I want to see. And I'm going to keep calling your mamas if you keep doing it too. Go to Kid Blog. Answer the questions that came out of your brain so I can see what you are learning. And if I need to go back and redo something. So go to Edpuzzle, look at that States of Matter rap song, and then go to Kid Blog and go to the assignment, Changes in States of Matter, and complete your assignment. Have a great day.